Chapter 1, Lesson 4, Precalculus, going to do some examples where we compose functions and then determine the domain of the new function. So the first couple functions we'll take are kind of easy, so we'll deal with those first. So we're going to take f of x function, which is 3x plus 2, and the g of x function, which is equal to x minus 1, and we'll do fog, we'll compose g with f, and then we'll do goff, where we will compose f with g. So we're going to do g composed with f, or excuse me, f composed with g of x first. And again, the second function is the domain that we're going to be interested in when we get to the new function. So let's determine that domain first. The domain of this g of x function, because there's no denominator and no radicands, is going to be all real numbers. So we will consider that domain once we compose. Now, composing g, or f composed with g of x, means we take the g function, which is x minus 1, and we substitute it into the f function. So this is going to be what we put in for x. So we're going to have 3 times the g function plus 2. So we'll go ahead and distribute that, and then we'll simplify that. So we get 3x minus 1. This is f composed with g of x, is this new function 3x minus 1. Then we want to consider the domain of the g function, which is all real numbers, and we want to consider the domain of this new function. This new function does not create any new restrictions at all, because there's, again, no denominator and there's no radicand, so the domain of this function here, which applies to this function, is going to be the same. So the domain of our new function will be all real numbers as well. So if we just slide this over, we'll see that we have 3x minus 1, and then again our domain is all real numbers. So let's go ahead and now take the same two functions, but this time let's compose g, or f, with g. So g of f composed with x. Alright, so again, we're going to put the f function into the g function, so I want to look at this domain first, which is all real numbers. So again, that will be the domain that we'll look at after composing. So substituting the f function in for the g function, we get 3x plus 2 minus 1, so we're going to get here 3x plus 1 as our new function. And again, this new function does not create any new restrictions on the original domain, so the domain of our new function is also going to be all real numbers. And if we slide this over, we can see that this is all real numbers as well. Alright, let's take a look at some examples that might be a little bit more challenging. Okay, so we have these two new functions. F of x is x squared minus 1, and g of x is 1 over x minus 1. So again, we're going to consider composing f composed with g of x first. So the g of x function is the one that's going to go into the f function, so we'll want to consider this domain first. And this domain, because it has a denominator of x minus 1, we realize that 1 cannot be used as a number, so our domain would be all real numbers except 1. So this would be the integral notation for that. Now we're going to take this domain and put it into the g function. So we're going to have the g function 1 over x minus 1 squared minus 1. If I simplify that, really all I need to simplify this is square numerator and denominator. I come up with my f composed with g of x function as 1 over the quantity x minus 1 squared minus 1. Now, we have to then consider the g of x function and this new function. This new function does create a restriction, and the restriction is x cannot be 1. Again, we cannot substitute in x here. That would give us a denominator of 0. Now, is that anything new, any new restriction on the original g of x function? And the original g of x function also restricted 1, so the new function does not create any new restrictions. So the domain of this new function is going to be the exact same domain as the original g of x function, all real numbers except for 1. So if we slide this right over here, we can see that it's going to be all real numbers except for 1. So let's take the same two functions, and compose f with g this time. So in this situation, because I'm composing f with g, I'm going to need to consider the domain of the f function. And the f function is all real numbers to begin with, so that's what we'll start with when we get our new function. So we're composing f with g, so the f function goes into the g function. So this is going to be 1 over the f function, x squared minus 1, minus 1. So that's going to be 1 over x squared minus 1, minus 1, which is 1 over x squared minus 2. So g composed with f of x ends up being this. Now this does create a restriction. So while the original function has no restrictions, all real number, the new function does create some new restrictions, so we want to determine what those restrictions are. So in this case we have x squared minus 2, which is in the denominator, so that means it cannot be 0, which means x squared cannot be 2, which means then that x cannot be plus or minus the square root of 2. So again, because we have a plus or minus, we remember that we want to treat this like absolute value, meaning that the domain means that the x values cannot be numbers that are equal to the square root of plus or minus 2. So positive square root of 2 and negative square root of 2 cannot be used. So this negative square root of 2 over here and positive square root of 2, these numbers cannot be used in my domain. So as I would write that in interval notation, that would mean I can go from negative infinity up to negative square root of 2, but I can't use it. I jump over the negative square root of 2, and then I can go up to positive square root of 2. I can jump over that, go to positive square root of 2, then all the way up to positive infinity. So this would be the domain of my composed function 1 over x squared minus 2. Sorry, I'm trying to squeezing this all into place, but I don't have a lot of extra space to work with. So this would be the domain then of my new function, and this being the composed function right here. All right. So I'm going to do one more example if you'd like to take a look at it. So our new two functions here, our two new functions here are x squared minus 2 and the square root of x plus 1. We're going to again compose g with f first, so I need to consider the domain of the g function. So this again is going to be all real numbers except for negative 1. So I can do anything up to negative 1, and then anything on the other side of negative 1 as well. Right? Then we're going to put the g function into the f function. So this is going to be then the square root of x plus 1 squared minus 2. So that's going to be x plus 1 minus 2. So this is going to be my new function, f composed with g of x is x minus 1. Now we want to determine, does this new function create any new restrictions on what we have already? And it doesn't. So our domain of our new function is going to be the same as the domain of the g function which we began with. So the domain of this function is going to be any real number except negative 1. And again, just to point out something that we talked about, notice this new function, if you looked at the domain of this new function independent of its composition, this would tend to think that would cause you to think that the domain would be all real numbers because there are no restrictions. However, because it came again from composing two functions, the original function characteristics are inherited, and so we have to consider that as when we consider the domain of our new function. So then let's take these same two functions and this time compose f with g. So again, the original function f is going to have no restrictions on its domain, so we'll consider that when we get our new function. So we're going to put the f function into the g function, so we're going to have then the square root of the f function, x squared minus 2 plus 1, which is going to give me x squared minus 1. So now again, as we consider this is a radicand, x squared minus 1 must be greater than or equal to 0, which means x must be squared, greater than or equal to 1. So x must be greater than or equal to plus or minus 1, taking the square root of both sides. And again, because we're dealing with a greater than or equal to and it's a plus or minus, we need to consider it in terms of absolute value. So the values of x that we choose to put in here must have a value larger than 1. So values larger than 1 would be this way on the positive side. Values larger than 1 would be this way as we're looking at the negative side. So this would be the domain of our function. The domain of our new function we'll put these additional restrictions on any domain restrictions that we have on the original function. The original function is all real numbers, so the only restrictions that we're going to have to impose on that are the ones created by this new function. So our domain for this new function is going to be from negative negative infinity up to -1, and that's included, in union with then from 1 up to positive infinity. Wrong way. We're going on this f composed with g of x. So right to there. Okay, and you can see again from negative infinity up to -1, and then from 1 on the other side to positive infinity. All right, so I hope those examples were helpful to you, and we'll see you the next time in class.